This week, we're going to look at how to write a local caching mechanism to help make accessing your data and fewer server requests easier. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for NSF Unidata. This week, I want to look at a viewer request, which is how can I write some sort of mechanism so that when I access remote data, a copy of it is stored to my local computer, and then I can retrieve that without having to make server requests and eat up bandwidth and tie up a server. But when I request data that I don't have, that data is retrieved from the remote server and stored locally. So we'd call this caching, and there are multiple ways to do it. There are even libraries like Pooch that is what MetPy uses, so you can retrieve and locally store things like county shape files and test data. But I want to show you that it's really not a complicated mechanism to write yourself. Doing this gives you a better understanding of everything that's going on, and it's really not that hard of an exercise, and one that can save you a lot of time waiting for all those remote server requests to return when you pull data and have some other little error in your code, and you don't want to have to pull all that data again. So let's get started. Of course, with imports from datetime, I'm going to import the datetime object. From pathlib, I'm going to import the path object. I'm going to import pandas as PD. And from siphon.simplewebservice.wyoming, I'm going to import the Wyoming upper air object, which tells you that yes, we are going to be working with sounding data. Now, why am I using sounding data as an example? Well, it's easy to get our hands on. It's not that large, so we don't have huge file transfers while we're recording the video here. And it's a great example of something that if you're doing a case study and accessing the same soundings over and over and over again, you shouldn't be hitting that remote server for the same data over and over again. But maybe you want to explore a larger time window, so you expand the soundings or expand the stations that you're looking at, and you don't want to have to go remember which ones you've got and which ones you don't. This is a great solution. All right, so we're going to write a few functions here. The first function is going to be get file name. It's going to take a date, which is of a type datetime. Notice I'm going to use type hints throughout now, at least in this MetPy Monday. It's something that we haven't talked about in a while, but it's a nice thing to do. And it's going to take a station, which is a string, and it is going to return a string that represents our file name. Use those triple bad quotes and leave yourself some documentation. Practice that empathy-driven development. Create a file name in the format year, month, day, hour, underscore station dot text. And that's going to return an F string of our date object that's passed. Going to string format the time, year, month, day, hour, underscore the station name that's passed dot text. All right, so there's our first function that is going to determine the file name that we're going to store the file as, or ask if we have that file. Okay, so I'm going to write a function to save data to the cache, to load data from the cache, and finally to get data. So this one I'm going to call save to cache. And it's going to take a data frame, which is a pandas data frame type. A file path, which is a path object type. And on that data frame, I'm going to call the toCSV method. Since this is tabular data, this is the easiest way to store it. We will save it to the file path specified. We don't want to save the index. And we'll print a helpful message to our user. It says data saved to cache. And let's show the file path. Okay, again, we need to leave ourselves some hints about what we're doing here. So it saves the pandas data frame to a text file CSV. All right. We've got something to save to the cache. Now we should write something to load from cache. This is going to take a file path, which is a path object. And what's it going to return? It's going to return a data frame because we're loading that data back out into a data frame. So we're going to print a message to our user, loading from cache file path. These are also helpful debugs for us. We might want to remove them if we were to put this into production of some form. We're going to use the read CSV function on the file path and return that. And of course, you could do more sophisticated file saving and loading if you've got more complex data, or it could just be saving a binary and comparing the file name. But we could go ahead and do transformations. We could attach units when we load from cache. We could do all kinds of things to make this more useful. So this is going to load a pandas data frame from the saved cache CSV file. Okay, so finally we need to write a function to actually get the data. This is what we're going to call as a user. So get sounding data. It's going to take a date, which is a datetime object, a station, which is a string, and the cache directory where we're storing our data, which is a path. And it's going to return data, which we've already said is a pandas data frame object. All right, so first we need to make sure cache exists or create it. So I'm going to check if the directory that we want to cache data in exists. And I'm going to say if not, cache directory.exists. EXISTS, there we go. Then cache directory.make directory. I want to make any parent directories that are required. And exist, I'm going to set that to true. Now, why do I need to do that? Because I've already checked if that directory exists. Well, I probably don't, but there is a possibility that in between those two calls, some other process could have made that directory. So this is just a good, robust approach to making sure that we're handling as many cases as we can think of. So I'm going to print created cache directory cache directory. All right. So the file name for the data that we want, I'm going to call our get file name function with date and station. The file path is going to be our cache directory followed by the file name. One of the cool things about the path library is it overrides the division operator, so you can create these operating system independent paths. All right. If the file path exists, in other words, if we have that data in our cache already, I'm going to call load from cache file path. Otherwise, we need to go get the data. So we'll say our Wyoming upper air dot request data for date and station, and then we call save to cache our data frame and the file path where we want to save it. Either way, at the end, we're going to return a data frame. Let's go ahead and leave ourselves some documentation here. So this is going to get sounding data from cache or remote source if remote store it locally. Okay, so that all looks good. I might go ahead and put a print statement in here. Loading existing. Again, these are probably going to be removed in production, if you will. And here we're going to put downloading new data. All right, so let's give it a spin and see how it works here. I'm going to define my cache directory using the path object, and I'll call it sounding data. So this is going to be relative to where I am in the notebook right now. So in the same directory, it will create the sounding data folder, which does not exist right now. So df sounding, my data, I'm going to call get sounding data, my new function. I'll give it the date time. Now let's pick a semi-random day here. Something a while back that we know is going to be in the archive, but not too far back. OUN is our station. Oh, and we didn't give it the cache directory. Okay, so it said it's downloading new data. It created the cache directory. That's good. Data saved to cache. And now if we look at df sounding.head, all right, we have our data. Now if I rerun this same cell, it doesn't create the cache directory because it already exists, and it says we're loading an existing file from the cache. You saw how much quicker that ran. So as you can see, making a little cache service that you can use to keep all of your research data locally is not that difficult of an exercise, and we can look at other ways to make this more robust. But as a first prototype, this is not a bad effort and saves you all that time waiting on data to download that you've already downloaded many times before. I hope that you found this useful, and I'll see you on next week's MetPy Monday.